Welcome to my new calculus channel. My name is John Gabriel, and today I'm going to talk to you about the unit and how we came to know of the unit. The unit is actually an abstraction, which the ancient Greeks realized long before anyone else came to realize. It is the starting point for the theory of numbers and the way we begin to measure all the things around us, whether they be distance, mass, volume, anything that can be measured with numbers. So let's begin. So the realization of the unit was a very big deal. And it wasn't realized just like certain people would say, in mainstream academia. For example, they'll tell you, oh yeah, that the unit is simply what everybody thinks of as one, but a lot of work actually went into realizing the unit, and it was a quantum leap when it was realized. So beginning with Book 7 and Definition 1, where Euclid defined the unit, and I hate to say this, but that definition written in ancient Greek is very difficult to understand, and I'm sure that Euclid and the ancient Greeks knew what they were saying, but it wasn't written down in the right way. Of course, they were brilliant beyond belief, and things that seem complicated to us were actually very simple for them. So the first definition, and I'll read it to you in a second, bearing in mind that I taught myself Greek. I've never been to Greek school. My mother was Greek, and we used to speak Greek at home. It was the first language I heard as I exited the womb. So let me try and read this correctly. It says, monas estin kath in ekaston don ondon en leiete. Okay, so if you try to translate that literally, it says something like unit is for every one being to be called, which doesn't really make sense as a word-for-word translation. But what it's really saying is that a unit is an abstraction, and what that means, I'll explain to you in a second how the Greeks actually arrived at the unit. But two translations by foreign academics are the following. A unit is that by virtue of which each of the things that exist is called one, and a unit is that according to which each existing thing is said to be one. But both these really don't seem to say very much. And the whole idea here is that you're supposed to understand this, but not on its own. You have to go back in the book of elements, in the books of the element, to understand what this means. Okay, so if we go to Book 5, which you have to start at Book 5 because Euclid began with the idea of magnitude. Now, magnitude is just the same as size or quantity. It's decidedly not a number. It's just a concept or an idea. It's the idea of how big, how small, how heavy, etc. So in book 5, I've written Book 7 here, but we'll go back to Book 5 in a second. But in Book 7 and Definition 2, we see the definition of number. Okay, it says in Greek, this line here, it says, arithmos δε το εκ μονάδων συγκείμενον πλήθος. Okay, and what that means is that a number is really composed of units or a multitude of units. And so Book 3 continues to elaborate more on how number would be used. It says, meros estin arithmos arithmou o elason του to mizonas. To mizonas, you see, even I have to look out for stressing the correct syllable. This is mizonos, not mizonos or mizonos. Otan katametri ton mizona. Okay, so what this is saying here is that the smaller number, or the minor, measures the major number, or the major part. Okay, so Ancient Greek is a very difficult language, and we rarely use these terms in modern Greek. So even for a modern Greek speaker, these things are not so easy to discern. So to arrive at the knowledge of the unit, we start off with the magnitude. Let's see, we can do it in 3 steps, okay? Just 3 steps, that's all we need. A magnitude is the same as size. It is not a number. It is only an idea, as I said early on, how big, small, etc. Excuse me. A ratio is the comparison of magnitudes, literally doing a qualitative comparison, regardless of the type. It can be a comparison of distances, masses, volumes, it doesn't matter. The Greeks used distance or length because that was the most logical and, of course, the easiest. So a ratio of equal magnitudes gives rise to the idea of a unit. But wait a minute. There are many ratios of equal magnitudes. And so because the unit is an abstraction, we have to choose a particular magnitude, a particular ratio of equal magnitudes to be the unit. And that's the same as deciding on a standard. So when you see a table of measures or units, that's what it means. It means a ratio of chosen equal magnitudes. Literally, for example, if you write A colon B, it means A compared with B. Or 1 colon 2 means 1 compared with 2. And that, of course, means 1/2. And if you say 2 colon 1, it means 2 compared with 1, where 1 is measuring 2, and that means 2. Okay? And that's it. That's how the unit is available to perform measure. So you'll see a lot of rubbish written in thousands of worthless books on how we got number, etc. And no academic before me and after Euclid realized these facts. I was the first to complete in a very simple and understandable way what Euclid had attempted to write down. But don't get me wrong, I'm pretty sure that Euclid knew these things, except he didn't manage to do the right job. And if he did, well, then it was only understandable to the ancient Greeks, because in their language, they would even omit entire parts of a sentence when, from context, it was understandable what was being said, right? So that's pretty much it for the unit, and that's what the unit really is. And then from the unit, we can continue to derive ratios of numbers, because now we have ratios of ratios which are natural numbers, which are simply a magnitude that is a multitude of the chosen unit. And that's how the perfect derivation of number is produced. And you can read an entire article of mine on LinkedIn called How We Got Numbers to understand not only how the number concept was derived, but all the arithmetic operations. My name is John Gabriel, and this is the New Calculus channel. Till next time, goodbye.